In section 7 of chapter 3, we're going to be doing things a little different. Because every lesson in this chapter thus far has been, hey, here's difference of squares. Here's a bunch of difference of square problems. Do difference of squares. Here's perfect square trinomial. Here's a bunch of perfect square trinomials. Do that factoring technique. Hey, here's an area model one. Just use area model. We just went over factoring by grouping. Here's a bunch of factoring by grouping problems. Do factoring by grouping. That is not how factoring is typically laid out. I taught you a technique and then gave you a bunch of pre-selected problems that technique works on. That is not the issue you're going to have with factoring going forward. The issue you're going to have with factoring going forward is they're going to have a bunch of problems and they'll say, factor. They're not going to say factor by this technique. You need to internalize when and where to use which factoring technique. That's what this lesson is. I'm not going to teach you anything new. I'm just going to give you a bunch of problems, and I'm just going to tell you factor. You get to pick which technique to use. Some of these will have multiple techniques that can be used on them. Some will only have one technique that can be used on them. It is your job to figure out what to apply when. Here's my advice. Always check GCF first. GCF is the easiest technique to employ, and on top of that, it makes hard problems easier. So I always use it as my go-to. Problem number 1, I have 4x to the 7th minus 36x to the 3rd. I'm initially just going to do GCF. I look at the numbers, 4 and 36, and I recognize, oh, they're both divisible by 4, so I'm going to pull 4 out. Additionally, I have an x to the 7th and an x to the 3rd power. They both have an x to the 3rd in common, so I'm going to factor an x to the 3rd out. That leaves me with x to the 4th minus 9. And then I need to ask myself again, are any of these things factorable? Well, once you get the 4x to the 3rd out, it's a monomial. It can't be factored again. So I look at the binomial. I have a binomial. The only way you can factor a binomial is if it's a difference of squares. There's a minus sign between them, so it is a difference. And x to the 4th and 9 are both perfect squares. So yeah, I could factor that again. This will become a 4x to the 3rd times x squared plus 3 times x squared minus 3. And then I rinse and repeat. I ask myself again, is that factorable? Well, x squared plus 3 is a binomial. Binomials are only factorable if it's a difference of squares. That's a sum. I have an addition sign. Can't factor it. Second one, I have an x squared minus 3. That's subtraction. So far, so good. The first term is an x squared, but the second term is a 3. The first term is a perfect square. 3 is not a perfect square. Therefore, the second binomial, x squared minus 3, is not factorable. So we're done. If that 3 was a 4 or a 9 or a 16, we could have gone another round, but it's not, so we're done. Problem number 2. I have a 30x cubed minus 52x squared plus 16x. I always start with GCF first. I look at the 30, the 52, and the 16 and ask myself, does anything go into all 3 of them? Yup, 2 does. Then I look at my variables. I have an x cubed, x squared, and x. They all have an x in common. So I'm going to factor out of 2x. That leaves me with 15x squared minus 26x plus 8. This is a trinomial. These are the ones that we don't like the most because it either has to be a perfect square trinomial or we have to use the area model. That's not a perfect square trinomial because 15 is not a perfect square. Neither is the 8. So I know it's not a perfect square trinomial. That means I got to use the area model. Draw my area model. The 15x squared goes here. The positive 8 goes here. And whatever ends up in these 2 boxes, they're going to have to add together to get me that 26x. I really hate this problem because the 15 in front of the x squared is not prime. You can get that by multiplying 1 times 15 or 3 times 5. And 8 is 1 times 8 and 2 times 4. You got to try all the possible combinations until you get to the right solution, which is this. Wait a second. I think there's a -1. My bad. Because that'll give you a negative x, and then that'll give you a negative 15x, and that doesn't work.
3x times x is not equal to 15x squared.
There we go. Thank you. I think I made a typo on this then.
The 5 should be in front of the x.
It should be. And then that would be an 8. That would be too big, I think.
It's 2 and 4.
It's 2 and 4.
Well, no, that's only 22.
You had 3x and then -4 and then -2 under the 5x.
Because that would give me,
-26.
that would give me negative 20. That would give me negative 6. There we go. Thank you for the help. That'll be 2x times 3x minus 4 times 5x minus 2. And now it's factored. My key was wrong. All right, and then problem number 3. Problem number 3, there are 4 terms. That means I have to use factoring by grouping. Therefore, I'm going to look at the first 2 terms. They both have a 4 in common. They both have an x squared in common. So it'll be 4x squared that I factor out of that. And I'm left with x minus 1. And then the last 2 terms, now you might look at that and go like, there's nothing that they have in common. However, I know I need an x minus 1 to show up. Right now I have a negative x plus 1. So what I'm going to do is I'm going to take out a negative 1. And that'll give me x minus 1. And now I can get x minus 1 times 4x squared minus 1. And this is what I was warning you about in the last lesson. This binomial is factorable again, because this is a difference of 2 squares. This is just 2x times 2x. This is 1 times 1. So it factors again into 2x plus 1 times 2x minus 1. And now it's completely factored.